Hello everyone, today we're going to be looking at problem 872 on LeetCode, leaf similar trees. So the question is basically asking to compare leaf value sequences of two trees, and a leaf value sequence is just in order the leaves of the tree. So for example, for this tree we have the leaves 6, 7, 4, 9, 8, and that's the leaf value sequence. So the first thing we have to do is actually get the leaf sequence of a tree. And we can do this recursively using an in-order traversal. So here I've written in pseudocode the recursive method that we're going to use to get the leaf sequence of our tree. So our method is going to take two arguments, a node and a list, where we're going to store our leaves. This recursive method is going to traverse our tree in orderly fashion, meaning we're going to start at the leftmost node and we're going to traverse the tree in order, meaning we're going to start here at 6, go to the next node in the order, which is 5, then go down to 7, up to 2, down to 4, up to 3, down to 9, up to 1, down to 8. I don't really have time in this video to explain how this works. So if you guys want, just look up a video on in-order traversal. I know there's plenty out there. Anyway, so the base case of our recursive method is going to be if node is null, then return. That just means if we hit a null node, we're not going to do anything. We're going to return to our previous method call. So first we're going to start at 3. It's not null, so this is going to be called. So this is our recursive method. We're going to be calling it on its left child. So we're going to do this until we hit our base case. We hit our base case, so we're just going to return. So we return to 6. This is when this condition is checked. If the left and right child of our node is null, that means we've hit a leaf node. That means we're going to store this node into our list of leaves. After this condition is checked, we're going to go down to this. Our recursive method is going to be called on our right child. The right child of 6 is null, so we're going to return. So we finished here with these recursive cases, so we're going to return back up to 5. And this is where the in-order traversal is. We have 6, we start at 6, now we're going to go to 5. Now, 5, after we finish checking the left subtree of 5, we're going to check this condition. And of course, it's not a leaf node because its left and right children are not null. So we're going to recursively check its right subtree. So we're going to go down to 2. 2 is not null, so we're going to call our method on its left subtree. Go all the way down until we hit null. We hit null, so we return back up to 7. This condition is checked on 7. 7 is a leaf node, so we're going to store it. Then the method's going to be called, we're going to recursively check its right subtree. Immediately we hit null, so we're going to return. And then we're just going to return back up to 2. This condition is ran. 2 is not a leaf node, so we're just going to go down to its right subtree. We hit 4. From 4, we're going to go down to the left. This is null, so we're going to go back up to 4. This method, this condition is checked, and it satisfies, so 4 is a leaf node. Then we're going to check its right child null, so we're going to return. Here, we went from 6 to 5, then our condition checked 7, then our condition checked 2, then our condition checked 4. So now that we're done with the whole left subtree of 3, we're going to return all the way back up to 3. Then we're going to check the right subtree of 3. We're going to go down to 1. 1, we're going to check the left subtree of 1, all the way down, go back up, figure out that 9 is a leaf node, we store it, check right here, null, we return up, we go down to 8, check 8's left, 8 is null, return back up to 8, 8 is a leaf node, we store it, go down to the right, nothing, turn all the way back up to 3, and we're done. So as you can see, you could kind of you can kind of see the in order traversal. Here, I'll use a different color. So we went all the way down to the bottom of our left subtree, our root's left subtree. Then our condition checks 6. So we go back up to 5. Our condition checks 5. We go down 5's right subtree, end up checking our leaf condition on 7. Then it's called on 2. Then it's called on, then we go down 2's right subtree. The condition's only true for 4. Go all the way back up to 3. Check 3's right subtree. After this condition checks if 3's a leaf node, it's not. All the way down the right subtree, figure out 9's a leaf. Check if 1's a leaf. Finally, we go down here, down the right subtree of 1. And our condition checks 8. So this is the overall explanation of how our code is going to look like and what's happening with our code. So let's actually go implement it. So now we're going to implement our method into LeetCode. So we have our method leaf sequence. It's going to take a node, which is going to start off at our root, and it's going to take an array list that stores all our leaves. So first we're going to implement our base case. If node is equal to null, we're just going to return. We're not going to do anything. Next, we're going to recursively go down the left subtree. So we're going to go leaf sequence node.left. And we're going to pass in, we're just going to pass in our array list. This is where we put our condition to check if our node's a leaf node. So if node.left equal to null and node.right equal to null, then we're just gonna add our node, or more specifically its value, into our list. Then we're gonna go down the right subtree recursively. Leaf sequence node.right. Pass in our same array list, and that's it. That's gonna be our method to check the leaf sequence. Now we need to create a new array list for both our trees. So array list integer tree, we'll go ls1 to new array list. Okay, I'm gonna copy this. Oops. And then ls2. So we're gonna populate our array using leaf sequence, or leaf sequence on root 1, which is going to be our first tree, and we're going to go ls1, then same thing, I'm going to do it on our second tree. So now we have our leaf sequence for our first tree and our second tree. Finally, we just have to check if our two leaf sequences are the same. So we're going to do return ls1 dot equals ls2. So that should be it. Does it run? It does. Submit it. Beats 100%. Yeah. So for time complexity, it's just going to be O of n because we're just going through all of the nodes. So our function is just going to look like n plus n because we're going through all the nodes in both trees. And if we take big O of that, it's just going to be O of n. So hope you guys enjoyed. I hope that answered any questions you guys had on this problem, and thank you for watching.